Hello everyone. Today we have a special session on Python interview questions. So as to how to tackle various Python interviews. As you know these days that Python is a very well-known and highly sought after language. Okay, so there are a lot of people who work in Python who are looking for Python as language for different purposes. So Python spans across various different domains. Okay, so typically people might have heard of Python basically as a scripting language or as a web application development language or something similar on those lines. But it is not limited. It is not limited to just that. Python can go way beyond this particular scope. So as defined as the current market trend. So if you take a look, let me just show you. If you just take a look at Python jobs, okay, Python jobs these days, you will be able to see that there are a whole plethora of jobs available as such. So let me just take up one single example. Okay, so you've got people who are looking for jobs in Qt based development, you've got DevOps, you've got software development with other languages, you've got jQuery, which means to say this is front-end development. You've got for SOA, distributed architecture. So you've got it in cloud computing. You see there is NumPy CMath, which means to say it is data analytics. So you've got a whole lot of domains where Python can actually apply. Okay, so from the industrial standpoint, Python is heavily used in web application, in backend development, in core application development, all these particular things. And to make your job easier, so it is also used for data analytics. It's such an easy language that you can use it for data analytics, web scraping, and a whole lot of others. So let's move forward. So as per Indeed.com, okay, just taking at the Python trends, you'll see the percentage of matching job postings across the various years. So 2012, I span back way before 2012. I go back into 2007, 2008, even before that. So back then it was a little lower, much lower actually, because it was not predominant. Now you'll see that there are heavy spikes, there are a couple of falls, but it is still spiking upwards. Even with the dawn of new languages, new framework, you see that Python relentlessly goes forward, and people still keep on adopting it. One, because of the ease of use. Two, because of the the simplicity of the language. Okay, and three, it pays a lot. So to actually show you the details, you see that the annual salaries of developers based on languages. Okay, you have ASP.NET, you've got PHP, Python, Ruby. This is just a general statistics that we have got over here. Okay, they've been moving on pretty much the same level, but you see that Python has never reduced, and in comparison, the salaries in lakhs per annum. This is in Indian lakhs per annum. Okay, so the starting salaries here has been given for 1 to 2 years of experience, anywhere between 2.5 to 4 lakhs. For 2 years of experience, anywhere between 4 plus, and for 4 plus years of experience, it is close to 8 lakhs per annum. But I wouldn't really comment exactly saying that this is what you're going to get. It depends on which particular domain you're joining into, which particular company you're joining into. There are a lot of factors which are involved as well. But I would definitely say that it is well-paid language as such. So there are people who have 4 to 6 years of experience earning close to 10 to 12 lakhs per annum as well. Okay. Now, the agenda is basically to get into the various interview questions that you probably need to tackle. These are a couple of tentative questions that you could face. So you could have a whole lot more. So I will get into a couple of them so that you get a better background. If you do have a question, a specific question, we could probably tackle those as well. All right. Now, so we will be tackling basic Python questions, Django questions, web scraping, and data analysis. Okay. Now, basic Python questions. So when you're talking about basic Python questions, there are a couple of specific questions which keep repeating. Okay. Now, this is the first question that we have. What is the difference between a deep and a shallow copy? So even before I get into this, let me just check with you all. So can you give me a background as to which particular background do you come from? Do you come directly from Python? And what do you want as a takeaway from this particular session? So I would be happy if you could reply in the questions box, please. A quick introduction into basically what you are looking for in this session as such, and what do you want as a takeaway. Okay, while you answer that, okay, let's tackle a couple of questions there. Okay, so as I said, basic Python questions. My suggestion would be to get yourself familiarized with the various data structures that you have in Python. Okay, that is the most heavily asked, it's heavily asked as such. So you've got questions like, what is the difference between list and tuples? What exactly do you mean by mutable? What is immutable? So you've got a couple of questions like that. Okay. All right, so Roma, you basically come as a Java developer. You're expecting to learn Python and know what you should focus on so as to move into Python. That's a great thing to do because you would find it pretty easy to move into Python as compared to working in Java. So we'll take a look at this. Okay, let's go into the basic Python questions as such, what you would typically come across. So what is the difference between deep and shallow copy? Okay, so let's do one thing. Okay, let me open up a Python prompt. Okay, now, so even before we get into this, let me just give you a background. So what do you mean by a shallow copy? It means that it is used when a new instance type gets created and it keeps the values that are copied in the new instance. So basically we are copying, okay, copying whatever is of the new instance from an existing instance. Okay, so it is used to copy reference pointers, it copies just the top level values. It doesn't copy each and everything and create a new object. So there would be references. Okay, for example, okay, I have L1 is equal to 1, 2, 3, 4. Okay, this is a particular list. Okay, I have a list L1, 1, 2, 3, 4. Now L2 is equal to L1. I'll create a, I wouldn't say it is a copy. It's just a reference of L1 in L2. So if I even do L2.append of 10, so it would reflect both in L2 and L1. Okay, this is this is basically a referencing. Python, Python referencing. Now, when you're talking about copy, we usually have a particular module named as copy. So the shallow copy works this way. So I've got L1. Okay, I've got L3. Okay, I'll create L3 copy of L1. Okay, if you look at L3, it is the same as what we have in L1. Now L3.append of 11, let's take a look at L1, L2, L3 now. Okay, L1 is at 10, L2 is at 10, and L3 has moved to 11, which means to say it has created a copy. Okay, this is a shallow copy. Okay, so it is used to copy all the reference pointers, it copies all the values, but it creates a new original by itself in a separate memory location. So to check the memory location, you can do this: L1, ID of L2, ID of L3. Okay, you see L1 and L2 are the same, but L3 is different, which means to say that there is a copy which has happened, but the admin structures in copy, so the admin structures of L1 are not copied to L3. Okay, so we will not delve into that depth because there's a whole lot more happening. Okay, there's a whole lot more happening. But what I can tell you is, if you were to tackle the question, this is what you need to say. Okay, L1, so basically your shallow copy copies all the reference pointers, all the values, and it creates a new memory location so as to you have a copy of the entire set which you created. Whereas a deep copy, it takes care of all the references of the references and a whole lot more, which means to say it has to make pointers to each and everything. It has to make clear-cut copies for each and everything. That does not happen in shallow copy. Please remember, that does not happen in shallow copy. Okay, so deep copy gets deeper and deeper. And when you take, copies of instances as such, that is where issues come in when you're using deep copy. So it makes it much more slower to run deep copies. Okay, it makes it much more slower to run because it has to copy all the references, all the admin structures, all the values, each and everything, whereas shallow copy does not copy all the admin structures, just the top level references and the original values. That's it. Are you all clear on the copy and the deep copy? Yeah, so the example for deep copy would be something like this. Okay, L4 copy dot deep copy, in case you were asked about that. So L2, okay, L4, ID of L4, you'll see it's got a whole different ID altogether. Okay, so this is how you create a shallow copy, and this is how you create a deep copy. Please remember this because it does come up, not frequently, but it's good to know something like this particular thing. What is the difference between copy, a regular copy.copy, what is a deep copy, and what is a regular reference? Are you all clear? All right, great. So let's move on. Okay, let's move on. So the next question, this is a very frequently asked question, that is, what is the difference between a list and a tuple? Okay, what is the difference between the two of them? Now, we already took a look at list as such. No, let's do it again. These are all lists over here. 1, 2, 3. These are all lists. Animals, marks, and comments are all lists. And the tuples are the one within these lists. So let's go back here. Let's create X or L1 again. 3, 4. Okay. And T1 as a tuple. 2, 3, 4. Okay. So here's the difference. Okay. Lists are data structures which can be modified at runtime, whereas your tuples cannot be modified at runtime. Okay, we have list methods which allow us to do that. For example, list.append of 10 will allow you to do it. This happens at runtime. Okay, but we cannot do that to a tuple. Okay, we cannot do that to a tuple. We'll see that it does not have such attributes. So you might wonder, why do you need tuples when you have lists? Okay, the reason being, when you have fixed data and you know exactly the size of the data which is coming into you, okay, or coming into your server or coming into your application, that is when you use lists, because these take up fixed or static space. Okay, whereas your lists are allocated space which is dynamic in nature. We can append, we can remove. For example, list.l1.remove of 3, and you'll see that 3 has been removed, so you can keep on modifying it, whereas your tuples are fixed in nature. When you're thinking about fixed amount of data coming in, fixed amount of data going out, and you are thinking about memory intensive tasks, always go for tuples. When you are thinking about buffers, when you're thinking about queues, when you're thinking about stacks, always think about lists. Am I clear on that? So the first question which might come up would be, what is the difference between a list and a tuple? Basically, a list is mutable, a tuple is not. Am I clear? Could you reply with a Y or an N? So for example, okay, still unclear as to where to use tuples. Now you have got a database, okay, MyDB, okay. So for example, I've got fixed columns, okay, column with ID, column with name, and a column with marks. Okay, so the list represents the rows. Okay, so this is one row, this is the second row. Something like this. Okay, when you know exactly how many columns you have, you go for a tuple. When you don't know how many rows you have, you go for a particular list. That is how it has been, it is structured. Even all the APIs, MySQL, PostgreSQL, SQLite are all structured this way. Okay, where the columns are represented by tuples and the lists are represented by rows. Okay, so when you are writing in data, you have fixed number of columns, so you have a fixed number of data. You cannot simply tell, I want to write n number of columns into an n-1 number of column database. Does that make it more clear, Roma? All right. Okay, so that is about lists and tuples. And there is one more thing. Okay, you might get a question like this. Okay, say L1 is equal to 1, 2, 1, 3, 4, comma, and I would put in a tuple inside this. Okay, so let me ask you a question. will you be able to modify the list? Okay, so modify the list, or will you be able to modify the tuple? The tuple exists within a list, which is a mutable thing. Okay, and here I'll give you something like this: 1, 2, 3. Okay, so you've got L1 and you've got L2. Okay, will you be able to modify this tuple? Could you all reply? From my explanation, you should be able to answer this. So here's the thing: tuple you will never be able to modify. Will you be able to modify this list which is inside the tuple though? So you say, I don't think so, but it is, you are able to modify it because it is referenced, as I said earlier. So if you see L2 now, it would have been modified. Remember, lists are referenced when even inside this, the structure, the attributes of a list do not change even if they are inside a tuple. It's a tricky question for beginners. It does come across. All right. Now, how do we achieve multi-threading in Python is a question which comes up. Okay, so Python does have a threading package. Okay, so it's got a threading package, it's got a multi-processing package. There are two different concepts. Threads are related to specifically threads, and multiprocessing is specifically related to the number of cores which you have on your system. Okay, now Python has something called a GIL, global interpreter lock. This is a question which comes up. Okay, typically when it comes to threading, this is a question which comes up as to what is a GIL. The GIL is a global interpreter lock which makes sure that only one thread can execute at a certain point of time in Python. Okay, so what happens is that the thread acquires the GIL, it completes the work and moves on to the next thread. So if you're talking about multi-threading, this is what typically happens. Okay, you've created multi-threads using the threading package. Okay, what happens is that it moves from one thread to the other thread to the other thread, so that it seems as if it is executing in parallel. Okay, it's executing in parallel. But what is happening is it is actually taking turns using the CPU core. It looks like it is executing faster, okay, but not necessarily all the time. But there is a particular way. It's a dirty hack, if you might say. You can, however, turn off the GIL over here. Okay, it mimics. Okay, so it does not happen parallelly. It mimics parallelism, is what I would say. Okay, it mimics parallelism. But there is a way to do it parallelly also, where you can turn off the GIL. Please remember, this is a very, dirty way of doing it. So if you turn off the GIL, your memory management can get messed up. So typically they don't do that. There are other packages which have come in, which makes better use of threading. Okay, so you have to be very careful while using the threading package as such. So when you're turning off your GIL, you have to make sure that you write your semaphores, your mutexes properly so that it does not mess with your memory management. Okay, because Python memory is internally managed by the Python interpreter itself, unlike something like C or C++, where you have to do the memory management part. Okay, so is that clear to you all? So GIL can always add an overhead to your execution. Okay, I'm not saying don't use multi-threading. Okay, I am saying multi-threading is heavily used. Okay, it's just that it is used depending on context. So in case you have a lot of cores, it makes sense to use something like threading. Okay, is that clear to everyone? Okay, beside multi-threading, you can make use of multiprocessing, where multiprocessing takes advantage of the number of cores you have. So if you say I have got 4-core processor, you can make use of all those 4 cores and run parallel jobs on all those 4 cores. Okay, so you've got something called multiprocessing for that. Okay, library called multiprocessing. For threading, you have something called threading. Everyone, are you all clear? Okay, great. Now, basic Python questions when it comes to ternary operation. So I wouldn't call it exactly ternary. It behaves like a ternary operation. Okay, so where you have conditionals, if X or Y. Okay, something like this. So how does it work? Okay, so basically this is how you do it. So you've got X and Y. Okay, X comma Y is equal to 25 comma 50. Let's take up this example. Okay, 23 comma 50. We need to find the largest among these. Okay, so you have to be sure as to what you're doing. X, if X greater than Y, else Y. Okay, if X greater than Y, else y, which means to say it evaluates for x, so it will give x if x is greater than y, else it will give y. So when you check big, you would have got this particular answer. Okay, so the expression gets evaluated like this, x less. So in this particular case, this is not x greater than y, it is x lesser than y. This is for x, the smaller one. Okay, so it's not big, it should be small instead. Okay, so is true. So if x is greater than y, return x, else return y. That is what basically happens here. Are you all clear how to use, how to mimic a ternary operation? Great. Now, what is monkey patching in Python? This is something which appears when you have gotten into classes as such. Okay. Now, so basically it means to say that you're applying a patch at runtime. Okay. Or basically dynamic modifications of class or a module at runtime. So basically what happens here? So let's quickly create this example, recreate this example over here, and then I'll tell you what is the use of monkey patching. So please remember, do not follow this particular thing, follow this particular syntax, because I am using new style classes. This is a question which comes up again as well. Okay, do I use old style classes or new style classes? This is something called an old style class. This is using new style classes. Always use new style classes. It is only legacy architecture which makes use of old style classes. New style classes where the classes inherit from objects, an object parent class as such. Def f self. Okay, I'm creating a particular function, print. So it says that just print this in case you are invoking me. Now, okay, I will import something like m. So typically I would import it from a separate Python script as such. Over here I'll show it to you directly in practice what exactly you're going to do. Okay, monkey self, print monkey f. So basically this is going to be your patch which you want to apply to this particular function in this particular class. Okay, so what you're going to do is my class. So if you do my class.f now, let me instantiate this class first. X is equal to my class x.f. Okay, so you see that f is printed over here. Okay, now my class.f. Okay, so f becomes a function attribute of this particular class. Okay, now is equal to monkey underscore f. So I am forcing this onto this particular function. Okay, now what happens? I will create an object obj, okay, which is my class. Okay, obj.f will give you monkey f. It would have applied this particular patch onto this particular function. Are you clear as to what happened exactly? So we are applying a dynamic change for a particular function in a particular class at runtime. Did you all understand how it is applied as such? We are forcing a particular function into a particular function attribute of a particular class at runtime. Did you all understand? So what happened here is that you have a particular class which contains a particular function f. Okay, so this particular function is completely independent of everything else, which is part of this class. It is only part of this class. Now you create an additional function called monkey f, so which you want to patch into this particular function of this particular class. Do you follow me so far, Roma? Okay. Now what you are going to do, so initially if you are calling directly from that particular class, my x is equal to my class x.f, it will give you this f, and this is the one which was found earlier, which is naturally a part of that particular class. Okay, now what you do is you are going to create another function which is not part of this class. Remember, not part of this class. You create a function, okay, and you have a different working of that particular function, and you want to patch it for this particular function which is part of the class. Okay, you are going to force this particular function, which is why you do my class.f is equal to monkey underscore f, where f is the function of this particular class, monkey f is your patch function. Following me so far, everyone? Okay, now what I do, I create an instance of that particular class after patching, and you see that patch has applied over here. So are you clear? Everyone, are you clear now as to what exactly I did? Okay. So why it is used is basically, it is used as a quick fix in case there are issues, in the code. Self is basically for the, similar to a it's not a constructor, it is a self definition for a particular constructor. Okay, so to create instances as such. Okay, now, so basically what you do is you create, patches so as to get dynamic attributes at runtime, which you were initially not thinking about, or, applying quick fixes so as to, at runtime, so that things do not go wrong. Maybe, something, there was a functionality and it is not working right. So you go ahead and apply a patch for that, something like this. Okay, this is how you do it without changing the class itself. Okay, now here is a question. Okay, how can you randomize the items of a list in place in Python? Okay, so this is a question which makes use of, something called a random. We have a particular module in Python called random. From random, import shuffle. Okay, you've got a whole lot of stuff within random, but you're not going to take it up. So what we'll do is we'll create a list. Just a moment. Okay, so we create this particular list. X is equal to keep the blue flag, individual items, and you want to shuffle this thing in place. Okay, you want to shuffle the original item. You do shuffle of X. When you print X, you see that the items have been shuffled. You do it again, you see that again it has been shuffled. Okay, this is how you shuffle items in place. Are you all clear? All right, super. Now, write a sorting algorithm for a numerical data set in Python. So maybe the question is not totally clear, but what we are trying to say here is write a sort for a data set which is a string. So basically integer strings basically. Okay, so 1, 4, 2, 10, 5 are a string, set of strings or list of strings, okay, which are all actually integers. So how do you do that? So there are two different ways of doing this. Okay, so let me do this. L1 is equal to 1, 4, 2, 10, 5. So 1, 4, 2, and 5. Okay, so one particular method is doing this. Now you have a string. So if you do L1.sort, so let's do this. Okay, now L1 sort will give you something like this. Okay, it is not the right thing. This is not right at all. Okay, and you wouldn't want something like this. Okay, what you want is 1, 2, 4, 5, 10. So when you do a sort like this, it applies on the ASCII characters as such. So it applies on the first found ASCII characters, which is why 10 will also come out of place. So when you want to do an integer one, this is what you do. This is the first one. L1 is equal to int of I or I in. You might be wondering what this is. So, and L1 dot sort. So now you see that it has been sorted in place. So what we did here is we use something known as a list comprehension, which can, traverse over a particular list quickly and, shorten your code. You create a list in place itself. Okay, which means to say for I in L1, that means we are traversing over L1 first, and we are creating an integer out of that particular thing. We are forcing it into an integer type, int of I for I in L1. First we change all the items into an integer, and then we sort it in place. Are you all clear regarding this now? Okay, similarly you can do the same thing in a different way by using another one. So L2 is equal to, you use map, okay, of int comma L2, okay, L2 dot sort, not L2 dot sort. Let's see, First, we change it into an integer. This is a very short one. Instead of using a particular list comprehension, you can use a map. Okay, map of int comma L2, and L2 is equal to 1424, and one L2 dot sort will give you the sorted items. So there are two ways of doing it. This is one way, and this is the other way. Okay, are you all clear? So map, what it does is it takes up any function, okay, and it maps it to a particular list of items. Does that answer all your questions that you have in mind? Roma, Madan, Varun? All right. Now, you have another set of questions over here, which basically are simple programmatic questions. So let's take a look at that. So T1 is equal to A, B, C, D, and T2 is equal to 1, 2, 3, 4, 5. Okay. There is a data structure. So you want to create a dictionary out of two different lists or tuples which have matching number of arguments. This is how you do it. Zip of T1 comma T2. Okay. What you get is a list of tuples which are zipped together. A, B, C, D, E. When you do dict of zip of T1 comma T2, you actually get a particular zipped dictionary which is created from the lists or the tuples. Is it clear with everyone? Okay, so this is the first thing. You want to create a list of items, okay, a list of integers from 0 to 9. You do it like this using range, a range of 10. Okay, now A2 is equal to sorted of I for I in A1 if I in A0. Okay, what it means to say is, first we are going to traverse over A1, which is 0 to 9. Okay, 0, 1, 2, 3, 4. If I in A1, so I will pick the value 0, 1, 2, 3, 4 till 9. It will check whether the value of I is present in A0. Okay, A0. Where is A0? So basically your A0 is equal to, just a moment. Yeah. So you'll not get that. A0. Okay, so what happens is that you get it as an empty list. Reason being, it searches for, when you check for A0, A0 is a dictionary, okay, and it checks for the keys to be 1, 2, 3, 4, 5, and it is not. It is the values which are 1, 3, 2, 5, 4, whatever it might be. Okay, it is the values, not the keys. All right, which is why you get an empty list. Similarly, A3 is equal to sorted of A0 of S for S in A0. Okay, so we are traversing over A0 first. Okay, we are traversing over A0. We are traversing over the actual keys as such, A, C, B, E, D. Okay, so it checks for A0 of S. Okay, we check for A0 of S. So what happens? We get it as 1, 2, 3, 4, 5. You get the values for all of them. Similarly, A4 is equal to I for I in A1 if I in A3. Okay, so we are traversing over A1 this time, and we are checking if this 0, 1, 2, 3, 4, 5 is present in A3, which is actually present. Okay, and when you do A4, you see that it will give you the values for 1, 2, 3, 4, 5. Now A5 is a dict comprehension. This was a list comprehension. This is a dict comprehension. Now I colon, so I would be your particular key. Okay, I colon I into I. That is, we are creating a particular square of the item for I in A1. A5 will give you 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, so on till 9. Okay, so we are creating a dictionary comprehension by using this for I in A1. Okay, we are traversing over A1, which is a particular range of items. And finally, A6 is equal to, we are creating lists of items I into I for I in A1. A6 will give you the same thing as a list of a list. So are you clear with how these work as such? From a very top level, are you clear with how these work? Very nice. Now, there are some more things. Now, when it comes to regular expressions in Python, okay, how do we do various things in Python? So we've got an RE module. So we've got split uses a regex pattern to split a given string into a list. Okay, so split, it uses a regex pattern. Sub will find all the substrings where the regex pattern matches and replace them with a different string. Okay, and sub n will replace it like it does in sub, but it will give you how many replacements happen. Okay, for import RE, okay, my s is equal to something like blah blah blah, something like this. Okay, you have a regex pattern, regex pattern is equal to blah, something like this. Okay, so what you do is my s dot re dot split of my s comma pattern. Okay, okay, so the best way of doing it is typically doing a normal split. Okay, so let me do this. Okay, so what it does, it splits over the pattern BLA. Okay, BLA, BLA, BLA. The first one is an empty string, then it gives you H, H, and H pattern, comma, the string which you want to do it for. Okay, substitution. Okay, I'll do it for S sub n because it works similar to sub. Okay, re dot sub n, okay, of your pattern, that is blah, comma, your string, okay, which is my s. So you've got your pattern. Okay, replace blah with, sorry, I missed out this, a with pattern and my s. Okay, so it will replace the blah with BL. Okay, it will replace with a particular a. So if we take it the other way around, pattern comma a minus, so it replaces BLA by a, only a. Okay, did you get it? How it replaces a particular pattern? Everyone, are you clear with how it replaces a particular pattern? Okay, so let me go back again. Okay, so you've got your string my s, you've got the pattern which needs to be replaced. Okay, and you have an item, replacement item a. Okay, re dot sub n, okay, re dot sub n, your replacement item, your pattern which needs to be replaced, and your string, okay, would be this way. But if you go this way, your pattern, your replacement item, and your string will do it this way. Take your pattern, replace it, replace all the items in your pattern with the replacement item a, and you get AH. So BLA is replaced with A, and it gives you how many times it has been substituted. Are you clear now? So Roma? Okay, so let's continue with our questions. What is inheritance in Python? Okay, inheritance is basically gaining the attributes and methods from one class into another. So from the parent class to the child class, or from the base class to the subclass as such. Okay, now, so there are different types of inheritances. Okay, so there is single, there's multi-level, there is hierarchical, and multiple. So typically the highly used ones are either single inheritance or multiple inheritance. Now, how does it actually function? So, where a derived class acquires the members of a single superclass is known as a single inheritance. Multi-level is, one class derives from, another class, which derives again from another class. So basically, a derived class is inherited from a base class, and the other one inherits from the previous class as such. So D1 inherited from base class B1, okay, and D2 is inherited from, there's a mistake here, it, inherits again, from that particular class. Hierarchical is base, one base class you can inherit multiple child classes. So basically it might be something like this, hierarchical. So my class M class, my class, M2 class of my class. So this is hierarchical inheritance. You have to be careful while using hierarchical inheritance, because if you are instantiating both the classes, you have to be sure as to which one you are going to use. If it is going to be using from M class, or is it going to be from M2 class, if it is deriving from the same one. Okay, you have to be very careful, especially with the functions which have been derived from the base class as such. Okay. Now, multiple inheritance is where you derive from multiple classes. Okay, it is from multiple classes. So my class so another class will derive from my class, comma, my C2. Something like this. So child will derive from two different superclasses as such. Are you clear as to what exactly inheritance is? So you've got an example here, v1 v2 child class, parent class, pass, and v1 and v2. Okay, so this is basically what you mean by inheritance in Python. Okay, moving on to the next part. It might not be relevant to everyone, but people who are moving into web application development and specifically to Django might find it relevant. Okay, now this is a question. So mention the Django architecture. So there are various patterns which are available. So you've got MVP, you've got MVC, you've got MVT. Now MVT is a model, view, and template. It is similar to that of MVC, which is model view controller, but here what happens is that model is similar to both of them, both MVC and MVT. The view over here functions as a controller itself. Okay, and this V, the view in Django, functions as a regular controller. It takes care of all the controller aspects. Whereas the template, the T, okay, is similar to the view, MVC. So basically view, it is the T, that is template, is similar to the V in MVC, that is the view in MVC, because T is basically the templating part where you have your HTML templates, your text templates, you've got different types of templates, typically your HTML templates. Now, you've got your model, which is part of your database, where you define your database as such. Your database schema is defined in the model. The view and the template maps the model. So basically the developer provides a model and the view, and the template then maps it to the URL, and Django does the magic to serve it as such. Okay, you've got the model, you've got the template. It is then taken up into the view and given as a URL through Django to the user. Are you all clear regarding the model, view, template structure as such? So templates would be your regular HTML pages which contain dynamic elements in them. Okay, for example, let me just give you a simple template as such. For example, I have something like this, HTML/HTML head /head body /body. Okay, your head can contain dynamic elements. Okay, my title, something like this, a variable called my title, where let me just do this 1 second. My body, something like this. So my title and my body are information. This is a template. Okay, so the view will pull up information from the model. Probably all the titles and body information is in the model. Just an example, okay, is inside the model, which is inside your database. So what it does is it takes up the title, it will populate it with the title. It takes up the body, it populates with the body, respective body, title, body, title, body. So you can have hundreds of items and you can have a single template serving different types of templates. Does that answer your question, Roma? Okay, so now explain how you can set up a database in Django. So we'll go with a default database, which is SQLite, which stores data as a single file in the file system. So you can also have databases like Postgre, MySQL, Oracle, MS SQL, other than SQLite. But then you need to use your administrative tools to create a new database. You know, for example, you might have to use something like 𝐶alchemy or something like that, okay, to create your database as such for your project. So basically, either way, with your database in place, it tells Django how to use it. Okay, this is where your settings.py file comes in. So you, in your setting.py file, is where you do all the configuration regarding that particular database, or your web server information. All these things go into your setting.py file. So you've got your databases. So databases will tell you the default, or your standby or your slave or whatever it might be. So the default database you typically have a SQLite. So you give the name of the engine, database DB backends, SQLite 3, because SQLite 3 is your particular database, and you direct it to a particular base directory name. So base dir has to be also mentioned over here, and db.sqlite 3 is your actual database. Okay, it is going to be the name of your particular database. Okay, similarly, there might come another question as to where do you start your, where do you have information regarding starting your web server or anything like that. So that comes under something called as manage.py. You've got another file called manage.py. So be sure about setting.py and manage.py. Are you all clear on that? All right. Now, how do you write a view in Django? So we talked about templates. I also showed you a simple template which we have. Okay. How do you write a view? Okay. A view is similar to a controller which pulls up information from your model and your template and serves it to the user. An example is like this. So you have a views.py file where you put from django.http import http response, because you are going to give out an HTTP response. Import date time. So what this particular view does is that it returns the current date and time as an HTML document. So basically you'll get an HTML response and an HTML file which shows the current date and time. So it will contain, it is now blah blah blah. Okay, say it is now, I don't know what time it is, so somewhere around 11:10. It will give you an output saying it is now 11:10 a.m. or whatever it may be, because it pulls the information from date time not date time not now, puts it in the HTML and replaces this %s by that information and returns you the HTML response. Now you might be thinking, what if I have template files available? So in that particular case, you have to first use the loader to load in the template by doing a get template. Okay, and then you have to serve the response over here by rendering the template. Okay, are you all clear? Okay, so you have getting the template, rendering the template, serving your responses, and how to write a view in Django. So what does Django template consists of? So it is a simple text file, as I showed you. It can be of XML type, CSV type, HTML type, and n number of other types as well. It can contain variables like I just showed you earlier, my title, my body. It can be replaced by various values when the template is evaluated, and the tags as well. You can change the tag information that controls the logic of the template. So you've got your database mod, which is controlled by the models.py file. You've got your views.py file. You've got a separate template folder which contains the various templates, and you have your URL or your URL views, which is your particular. So basically you create your root. These are all your roots, which are your URL, and you pull up your this URL root through the browser, and it will render the template and give it back to your browser. This is the workflow of a particular HTTP request as such. But what does a template contain? XML, CSV, and HTML as well. Are you all clear? Now this is a question which comes up. Explain the use of session in Django framework. Okay, now it is possible that you might get a question like, okay, so I have a particular user who's logging in at, say, 11:15. Okay, and he probably keeps himself logged in. Okay, and he leaves the particular place. Okay, and after like another 2 days, he comes back and he sees that he is still logged in. Okay, so how do I, this is another way of doing the same thing regarding session. How do I see to it that the user logs out after a particular time? So that is where you make use of something known as sessions in Django. Okay, Django provides a session that will allow you to store and retrieve data as per site visitor basis. So you will create a random session. It could be a random keyword as such, which would have the session data. For example, it might contain cookies. It will contain session ID cookie, so that it will be put from the client side, pushed to the client. It will serve on the server side. So in case your session cookie has a timeout, it will tell after 2 hours you're supposed to log out by default. So even if the person comes after 2 days and tries to enter that without a cookie is a session, okay, it will tell that you have been logged out, please log in again. That is where session IDs and cookies come into picture. Okay, so this is very good for security as such. Okay, it is very good for security. That way you are not pulling data from the server and storing it on your client side. Are you all clear what a session is? So it is a certain basically an ID which allows you to keep your users in check. Now, what are the different types of inheritance styles in Django? Okay, so there are 3 possible inheritance styles. So you've got abstract based classes, also known as ABC. You've got multiple table inheritance, and you've got proxy model. So what is an ABC? So the style is used when you want parents class to hold information that you do not want to type out for each child model. So basically you will have a particular parent class, okay, and you would want the parent class to hold information, and you do not want to create it for each and every child class as such. That is where you use an ABC as such. So ABC is also used to create particular classes, okay, which are not completely, implemented as such. It is a better approach than, just creating empty classes as such. Exactly, you cannot instantiate an ABC in Python as well. So you can, you have your child classes derived from ABC because it is an abstract based class, and you will not be able to, instantiate a base class as, abstract class as such. Okay, it has to come from the child classes which are created from that. Okay, similarly, you've got multi-table inheritance. So you've got an existing model, and you want to create a model based on that existing table. Okay, another particular model based on that existing table. So you don't have to write each and everything down. You can inherit from multiple table as such. Okay, you want to say you have a class called book, you've got an article, you've got 2 different classes. You do not want to create a particular class which has got all information regarding book and article from scratch. Instead, you can just derive from those particular classes as such. You can directly derive from those particular classes. But please remember one thing, you have multiple table inheritance. So by default, so it allows you to override basically existing functions as such, but in multi-table inheritance, it does not allow you to do that. Okay. Are you all clear on that? Now, what are proxy models? Now, proxy models, so you can use this model if you want to modify the Python level behavior without changing the models field. So you can create proxies where you are making changes to the actual database via an existing, what do you say, a proxy of the existing class. So you create a particular model. So model defines a particular table. Now you want to make changes to the table. Okay, you have different behaviors for that table. You can just create proxy models for that. By doing proxy models, you can have multiple behaviors without changing the actual behavior of the base model itself. That is where proxy models come into picture. Now, what is contained in a field class? So as simple as that, what is contained in a field class, a Django field class? So it will contain the database column type if it is integer, string, varchar, or anything like that. The default HTML widget available while rendering a form field, whether it's a text box, whether it's whether it's a particular email, you've got an email text field, something like that. You've got different types of field classes. Okay, you've got a password field, anything like this. So that is the default HTML widget and the minimum validation requirements. So number of characters which you can enter, number of lines which can be in the text box, all of this come in the field class. Please remember this: minimum validation requirements, default HTML widget, and the database column type. Okay, coming to the next section, that is web scraping using Python. These questions now. So how do you save an image locally using Python whose URL address you already know? Okay, so there are various ways of doing it. So this will work directly if you're using from your local. So your local, it would actually work directly. So typically what I would do is something like this: Python port requests, my URL is equal to www http google.com, this requests get URL. Okay, so you see that you are getting response r is equal to request.get. Let's do this with open of image.png comma wb as f dot write. Oh, sorry about that. It should be, let's see, read as right. This, sorry about that. I made a mistake in the syntax. Okay, we need to do encoding also because it is not allowing me to do r.text. It's giving you the encoding of the image. Okay, so this is the encoding of the entire image. We need to encode it and then write, and then you would have your image ready. You'd be able to save your image as such. Okay, you'll be able to save your image. All right. Now, how can I get the Google cache age of any URL? Okay, how do I get the Google cache age of any URL? Let's do one thing using the following format. So if you use webcache.google user content, so or open this up, you can actually do this. So your URL, for example, www.edureka.co. So you'll be able to get this information. So you'll be get the cache content. This is the cache content, okay, which has been provided by your CDN. Okay, so this is your cache content, and you'll be able to get the cache content by doing this webcache.googleusercontent.com search so and so. Okay, you can do this. Now, you are required to scrape data from IMDb top 250 movie pages. It should have fields, movie names, year, and rating. How do you do this? So this would probably come up as a coding question. Okay, typically not as complex. You might get a simple one. So how do you approach this? So you would have to get into imdb.com first, okay, and get the information first, this particular thing. Are you all following me so far? So you go imdb.com top no 250 movies. Okay, so there are various ways of doing it. Okay, but for this you have to start with beautiful soup. One is beautiful soup. From BS4, import beautiful soup. Beautiful soup is a parser, so basically an HTML parsing library. Okay, it's used for web scraping. It's heavily used for web scraping. Import requests. Request will get your information. Okay, so URL is equal to, so you have your URL. So soup, so you create your response, that is by using request.get URL. So you'll see that you will have a response 200, which means to say you've got the response object which contains the text, which contains all the information regarding that particular page. Okay, and you need the text from that, and you need to parse the text from that. For parsing it, this is how you go about it. First, open up the page, inspect this page, okay, and check what you need. So what you need is the fields movie name, year, and rating. There are various ways of, one such way is this particular thing. Soup.find children for movie in tr movie.find. Find is a command to get all the instances of this td, the td class containing column name, title, column. So class containing title, column. Similarly, year will be in title, okay, under your secondary info. Again, you have rating column, IMDb, you've got a whole lot of information, but that has to be first passed over here. Okay, so typically I would come here, go over here, and I would first do a check on this. So what I need is the TR content. You will see that you have got various TRs under lister list. Just a second, Roma. Let me just go through this. I'll tell you what exactly beautiful soup is used for there. So this is how you do it first. First you get this lister list. Okay, you have a list. So let's do soup is equal to beautiful soup. So you've got soup is equal to beautiful soup, right? So you are going to do this. Soup is equal to beautiful soup of rest.txt. So what is going to happen? It is going to create an object called beautiful soup out of the response that you have gotten. The response dot the text part of it. Okay, so if you check soup, it would have pulled up all the information and created a soup of it. Are you following me so far? Okay, now what you need is soup dot, so your question was soup is equal to beautiful soup. You need to find something. So soup dot beautiful soup, this is what it does. Now we'll do this. Okay, I want lister list. A list is equal to soup dot find. Okay, so dot find class. So you can do this, something like this. We don't want td, we want tbody. Okay, class is lister dash list. So this is supposed to find me one single item which contains the class lister list. Okay, a list. You'll see it would have pulled up that information regarding the tbody. Okay. Now the tbody, we need tr. Okay, so we have got a list soup dot find all. So TRs, my TRs are going to be soup dot find all TR. Let's check what we need under TR. Okay, TR, we just need the TR information. Okay, we just need the TR information within this particular thing. Okay, TR, not soup dot find all. So we want a list dot find all. Okay, I think this will not go in with that, or you can use find capital TRs. Okay, it'll give me all the TRs in this, all the TR information in this. Okay, now under this we need specific information. So this is how you go about it. Under this, okay, for TR in TRs. Okay, print, I'll just give you one example. Okay, post column, let's take this one for example. Okay, spec, you have something called title column. Okay, class title column. Now you get to the point of title column. print tr.find class colon find, we want td comma class colon title column. So one by one we enter into this part. Put it within quotations. Okay, so it fetches me all the title column information. Okay, so let's refine this some more. Dot text. Okay, it will give me all the title columns. You see all the title columns here have been pulled up. This is how you pull all the information. Are you all clear on how to approach this particular problem? Okay, next, data analysis using Python. Now, NumPy is one of the modules which are heavily used in Python. Okay, so how do you go about using this? So you will get a particular question saying how to get indices of n maximum values in a NumPy array. Okay, so you have to use these particular things. Import NumPy as np, arr is equal to np.array. You are going to have n number of items. Please remember this: 1 3 5 4 5 4 6 5, something like this. Okay, now you can make use of argsort. There is a particular thing called argsort. arr.argsort will give you the indices for this particular thing, okay, in a proper order. Okay, sorted indices. So what do you need? The top 3 positions. Okay, top 3 items. So -3 colon, so 2 4 and 3 of colon -1. So 3 4 and 2 is the answer which I get over here. Okay, what is the difference between the NumPy array and a list? So let me tell you this. Okay, just give me 1 second. So let me recreate this array: 1 3 2 4 5 arr.argsort of -3 colon of colon -1. Okay, 4 2 3 is the output that you want. Now, what do you want? So what you want is the difference between NumPy array and list. So we'll go get to that. Just give me a second. Import NumPy as np, a is equal to np.array. So we'll first do this particular. How do you calculate a percentile with Python? So we'll go to this first, okay, and then we'll move on to that particular question. We have got a couple of things, something like this. P is equal to, or we'll just do this, np.percentile of a comma the percentile level, the 50th percentile would be this 5. Okay, so you can return the 50th percentile. So you can directly feed in the percentile level and you will get the information regarding the percentile level. So this is a question which you asked Roma. Okay, what are the differences between NumPy and lists? Okay, so it is much more efficient because all the structures have been written in C. With Python, you have vector and matrix operations for free. So basically something like this. Okay, I have got L1 is equal to 1 2 3, something like this. Okay, so L1 arr is equal to np.array of L1. Okay, so we'll create L2 as well. Okay, now if you do L1 plus L2, say you want to add items of L1 to L2, so 1 plus 1, 2 plus 2, 3 plus 3, 4 plus 4, 5 plus 5 and 6 plus 6. L1 plus L2 regularly would give you something like this. But if you create an array with a NumPy array, This is what would happen. L1 ARR plus L2 ARR would give you 2, 4, 6, 8, 12. Does that answer one of your questions, Roma? Okay, so this is one of the examples. Okay, so you get a lot of vector and matrix operations, so that you can avoid unnecessary work of recreating those vector operations. NumPy array is faster. You get a lot of built-in with NumPy, FFTs, convolution, searching, linear algebra, histograms, etc. You've got a whole lot of stuff which is included. So what about the lists? So lists are general purpose containers, effective in regular insertion, deletion, appending, concatenation, etc. And it is dynamic in nature. Okay, but it does not support vectorized operations like element-wise addition, multiplication, division. All these particular operations are not supported, which is what the advantage actually is. Does that answer your question, Roma? Yes. So Roma, so NumPy cannot store different data types in a single array. It is homogeneous when it comes to a single array. But you can have arrays of booleans, you can have arrays of strings, you can have arrays of integer, float, etc. separately. Within a single array, it has to be homogeneous. Okay. Now, what is the difference between NumPy and SciPy? You've got something called NumPy, you've got something called SciPy. These are two different modules. NumPy is a much more raw module as such, if I were to say. So NumPy would contain nothing but the array data type and the most basic operations like indexing, etc. Your numerical code is typically inside SciPy. Okay, but you would see that NumPy and SciPy are quite compatible with each other, because SciPy is built on top of NumPy. So where SciPy has retained all the operations of NumPy, but it's got a whole lot of its own operations. For example, NumPy contains linear algebra functions, even though they are more properly utilized and they more properly belong to SciPy. You can contain integration, differentiation, all these operations are provided in SciPy. Okay, and it's much more easier. SciPy contains more fully featured versions of linear algebra modules. So if you're going to do scientific computing, it is advised to use both NumPy and SciPy together. Okay, which is a recommended thing. So instead of using it independently, you do not want, so it makes more sense of doing something like that. Okay, how do I make 3D plots or visualizations using NumPy or SciPy? So like 2D plotting, you have 3D plots, but you've got a basic 3D plot called mplot3d subpackage, which is part of your Matplotlib package. Okay, there is another package called MayaVi, which provides high quality 3D visualization features. Okay, for 2D, there is another beautiful charting library called Bokeh. It is based off of bokeh.js library. If you want simple charting, just charting, okay, you've got NVD3. You've got different types of libraries which can be used. You've got mplot3d subpackage for 3D, 3D. You've got for 2D, you've got Bokeh, which is dependent on the bokeh.js library. You've got, so with 3D, you've got MayaVi as well. You also got NVD3, which is part of the D3JS library. Okay, so you've got different beautiful charting APIs which you can use. Okay, now how do I find indices of an array where some condition is true? So you can simply do this np.array of, you have an array of 1, 2, 3, 4, 5, 6, 7, 8, 9. Print a greater than 3, you will find all the, you'll automatically create a boolean, boolean matrix as such. np.non-zero of a greater than 3 will give you the indices. So the output comes up this way. So let me just take that up. Okay. So a is equal to np.array of 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and you do this, print a greater than 3 and you get the Boolean array. Print np.non-zero of a greater than 3. All the non-zero numbers which are greater than 3 will be created as a non-zero index. So you might be wondering, what does this represent? So if you look at this, 1 0 1 1 1 2 2 0 2 1 and 2 2 are the actual indices. Okay, these are the indices. So this is 1 0 1 1 1 0 2 0 2 1 2 2. Are you all clear how that comes into picture? So these are the ones which are the indices as such. Okay, so you see this array. Okay, let me do this. So you see what we wanted is for all the items greater than 3. So how it comes up is you'll get two separate tuples. You have to take it parallelly with each other. 1 0, you see 1 0 index is for 4, 1 1 is for 5, 1 2 is for 6, 2 0 is for 7, 2 1 is for 8 and 2 2 is for 9. Okay, that is how it comes up. Now how do you rename column headers in Pandas data frame? So let's do this. Okay, import Pandas as PD. We'll take up this data, this piece of data, where we have a dictionary. Okay, we have a dictionary which contains lists. So you've got these would be your column names. Commander, date and score would be your column names, and these would be your entries, Jason, Molly, whatever it may be. Okay, data as so and so, enter. Next, you create a data frame out of the existing data with a certain index, whatever, in different locations. Okay, Pima, Santa Cruz, Maricoma, Yuma, etc. So you create a data frame with a specific index. So when you type df, you will see that you will get your values this way. Okay, you get your values this way. You want to rename your columns. So df.columns will give you all the column details, that is commander, date, score. You just simply do this, leader, time, score. You do this and check for df, it would have changed column names. This is how you change your column names in Pandas. Are you all clear? Okay. Now, what is a function used to iterate through values in a manner that one also retrieves the index? So for index comma row in df.iter rows, print index comma row. Okay, you will see that it gives you both the index as well as the column information. You have the index 𝐂𝐝 and you've got the column information, leader times score, leader times score. Are you all clear? This is how you can get the information. Okay, so these are the various ways of doing it. One other question. So how do you convert a list of dictionaries into a Pandas data frame? So we had that question earlier and we did that directly. So you had wait, let me go back, data. So you've got data over here, which is a dictionary containing all these items. So print pd dot data frame of data. So you'll get a data frame which is created, just doing pd dot data frame. Okay, that is how you simply create a data frame out of your dictionary. Okay, now so there's a question here. Let's say that I have a data frame df, which is a pd data frame of this particular type, pd dot data frame. Okay, so you see df is like this, and how can I subset based on a list of values? Okay, list of values is something like this. So it is a list containing values, simply a list containing values. We simply do y is equal to so and so. Okay, let's do this, one sec. List is equal to df of a. So we are now searching for a in list of values. We are searching for 3 and 6. Let's do one thing. One second. So df of a will give you this. We need in list of values. Okay, df of a for series is ambiguous. Use a dot item, a dot any, or a dot df. So we can do this. I think we have done a small mistake. df. We can also do this for df of a. For send list of values. So this is a little longer way. For if items in df of a, print items. So you can do this, but that does not give you the value. Okay, so we have to maybe get it to a certain point where it is. F of a of items, or the other way around. So I need to look into this. There's a slight mistake in this particular question. That's what I see. Okay, so basically you would be able to subset it based on the values. Okay, you can also do this. Okay, df of, okay, by doing df of a dot is in 3,6. So if you pass the subset directly, so through this particular method it is a little bit difficult, but it makes sense to use something like this. df of a is in 3,6. It will give you whatever is there for that particular subset, wherever there is 3 and 6. Okay, in a. Okay, so if you change it to b, you would probably get the value for only b, subset for b. Are you all clear? You can also do this. Okay, now you've got a data frame which contains both, you've got not a number. So you know that in a particular this thing, okay, in a particular data frame, we can have regular numbers as well as not a number if it has not been given, or there are mixed up numbers or mixed up with strings and all that. It takes it up as not a number. Okay, in that missing numbers, it takes up as not a number. In that case, how do you get only the ones which are not a number? So in that particular case, you just give this df dot is infinite is finite of so and so. For example, if we do it here, so it will give you only the finite values. This is just an example of what we had done earlier. So I don't know if I can replicate this. Just give me a second. Let me see if we can replicate this particular thing. Okay, so we can replicate this. Instead of that, let me just copy this over, put this, and put this as b. df. So you get only the finite rows. Are you all clear how to get only the finite rows? Is finite is going to be the thing which we are searching for. Now, there is a particular question as to how to write binary data using Python. So typically, this is a question which comes up when you're talking about picking up image files, or sound files or something like that. In that particular case, make sure to use RB. Okay, the RB mode, the read binary mode. F is equal to open file name read binary. You don't need import struct over here. So that is only for unpacking. So you don't have to bother about that. File name read binary. When you're reading it, S is equal to F read. Use 8 bytes. You need to use 8 bytes at a time. and read it. So that will allow you to read a binary file. It will give you the location and the byte value at that particular point. Similarly, f.write, if you want to do a write binary, you simply do f is equal to open of wb, and you can write information to it. You can also write image information to it. So an example which I have would be this. Okay, just a moment. So one more important library is the OS library. I'll give you another question. So how do you get the current working directory? This is by doing os.get. So I want to change the directory, okay, to Edureka/desktop/Edureka. That's how I'm going to do it. os.get.cwd will give me the current working directory. Okay, and os.list dir of get.cwd will give me all the files which are present. Now I am looking for an image file. Okay, I am looking for an image file. If items in, for items in so and so, if items dot, if img or png in items, or that print items. Okay, so I have a file by the name imgfile.png. Okay, so what we can do, so using this with open off, or we'll do this. So I want to do one thing. I want to copy over imgfile.png, okay, and create another file. Okay, I just want to copy it over. So I will be making use of both read and write. imgfile.png. Remember that you would have to do read binary first. Okay, g is equal to open my img.png dot write binary here, f.write.f.read. I will just go ahead and write everything in one shot. So g.read, sorry, f.read, g.write. Okay, g.close, f.close, and let's do that particular thing for searching for our files. You see, this new file called myimg.png has been created. Let's check if it exists. So you can see my img has been created as such. Are you all clear as to how to do this? Okay. So that brings us to the end of our particular session regarding interview questions. Thank you so much for attending today's session.